For this problem here, we're talking about variation. So what I did is there's some notes in 3.1.5, not sure that if everyone took it or not, that was talking about direct variation, joint variation, and inverse variation. It's really just talking about the key terms here, direct, joint, or inverse. Direct variation just means that y is equal to x if we multiply it by k, some constant. We don't know what it is. Whereas joint variation means that we're saying that y varies jointly with x and z when those are multiplied together and then also multiplied by some constant k. And then lastly, inverse variation just means that y is equal to some constant divided by x. So they're kind of these key terms that are going to be used in the future that we might want to know here. And the k is representing the constant of variation. So we're saying that y varies directly as the square root of x. So the way I write that is y equals the square root of x, and because it is directly, I multiply x times k, which, again, I don't know what k is. So that is the first part here. And so we know that that's y equals k of x. Then we're also given this information that y equals 11 when x is 4. So what that means here is that we can actually plug those values in to find my constant of variation. So I can actually plug those values in, 11 equals k times the square root of 4, and solve for k. So 11 equals 2k, and k is equal to 11 halves. So if we're then asked what is the value of x when y is 44, well, then we can kind of rewrite our equation here. Y equals, I know my constant of variation is 11 over 2, square root of x here. And now I just plug in 44 equals 11 halves times the square root of x. So I'm going to multiply by the reciprocal to get rid of 11 halves on the right side, which gives me just 8. Then I'm going to square both sides, so I get x is equal to 64 when y is 44.